Now we are discussing about the Charles law. According to the Charles law, volume of a gas is directly proportional to the temperature if we keep the pressure and amount of a gas constant, means moles constant. Temperature should be in the unit of the Kelvin. Volume of a gas is directly proportional to the temperature. If we remove the proportionality, we can write it as V equal to K into T, where K is the proportionality constant. So which we can determine with the help of the ideal gas equation, which can be written as V equal to NR by P into T. So comparing Charles equation with the ideal gas equation, we can find out that Charles constant is NR by P. So if pressure and moles remain constant and we change the temperature from T1 to T2, then volume will change from V1 to V2. So we can write it as V1 by T1 equal to V2 by T2. For example, if we take a case of cylinder and piston, if we increase the temperature from T1 to T2, if temperature increases but mole and pressure remain constant, then with the increase of the temperature, volume also increases. So we can say that V1 by T1 equal to V2 by T2. Now we are discussing the graph on the Charles law. Firstly, we are discussing volume versus temperature. Here temperature is in Kelvin. If we see the Charles equation, V equal to KT, it is Y equal to mx. If temperature increases, it means volume is also increases. So Y equal to mx means it is a straight line with a positive slope, and here the slope is equal to tan theta, or we can say that it is equal to NR by P. Next graph is between volume versus 1 by T. So the equation between volume versus 1 by T is V by T equal to K. So V is our y-axis and 1 by T is x-axis. So the equation is y into x equal to K, and the equation is rectangular hyperbola. So the next graph is between V by T versus volume. So V by T is our y-axis and V by T is always remain constant K. With the increase of the volume or temperature, V by T remains parallel to x-axis. Now we are discussing the application on the Charles law. Which of the following volume temperature plots represents the behavior of 1 mole of an ideal gas, the atmospheric pressure? There are certain cases in which we can solve the problem just by eliminating the options. In first case, with the increase of temperature, volume is increasing. It is correct. And for the ideal gas at 1 atm and 0 degree, 1 mole of a gas occupies the 22.4 liters. So now we need to find out that whether at 373 Kelvin the volume occupied by the 1 mole of gas is 38.8 liter or not. So this is correct or not. We look at the B option. At 273 Kelvin the volume occupied by 1 mole of gas is 22.4 liter, which is incorrect. So B option cannot be correct. Now let's see about the third option. For 1 mole of a gas, again the volume is 22.4 liter, which is correct. Now here we need to check out at 373 Kelvin the volume is 30.6 liter or not. In fourth option, this is logically incorrect. With the increase of the temperature, the volume should increase and it is decreasing. So both B and D options are incorrect. So answer should be either A or C. So we need to check out for A or C by applying the formula V1 by T1 equal to V2 by T2. Firstly, discuss option A. Here, if we are applying V1 by T1 equal to V2 by T2, placing the values by taking V1 22.4 at 273 Kelvin, and we need to find out what is the volume at 373 Kelvin. So the volume come out to be 30.6 liter. And here it is given to be 38.8 liter, which is incorrect. Hence, it means that The option A is incorrect and the correct answer is C option, where at 373 Kelvin the volume is 30.6 liter is given. So the answer is C part.